So, first thing I ask you guys to do is to write equations for these 4 situations, right? And something that'd be useful would be the definitions of direct and inverse. So, how do we do? How do we do? Does the first one make sense? Yeah? Okay, so that first one, it says acceleration and force are directly related, and acceleration and mass are inversely. So since acceleration and force are directly force on top, inversely mass on bottom. Does that make sense? Okay. Now the next one says momentum and mass are directly related, and velocity and momentum are directly related, right? It says the momentum of any object is directly related to the mass and velocity of the object. So what does this equation look like? Okay, remember, momentum is P, right? Right? Which was on our chart from yesterday. Momentum is P. So for momentum, we're going to use P, right? Directly related to mass. What does that mean? Where does the M go? Does it go on top of a fraction or on bottom of a fraction? What do you think, Jamila? On top. So mass goes on top, right? Where's velocity go? Next to it. Because P is directly related to both M and V. Right. Does that make sense? Okay. Number 3, the variable y is inversely related to x and directly related to z. Okay? So that means we're starting with y. Right? We're starting with y. And then we're inversely related to x. So where does x go? On bottom. And directly related to z. So where does z go? On top. And number 4. The variable r is directly related to t and inversely related to s. All right, you need a capital T down there. As soon as you start with r, right? That's directly to t. So where does t go? On top. And where does s go? On bottom. Does that make sense? Why is the t capitalized? Oh, I just picked the t. In the problem, I had number 3 and then lowercase t instead of capital T. I started a sentence with a lowercase letter. All right, that's okay. Good question, Faith. All right. So here I have the 4 equations, right? That bottom part down here, I know the marker trail is in the way, but the next part of this problem is we now have to write each of these equations in 3 equivalent forms. Okay? What does equivalent mean? The same, right? Now, when it says the same form, does it mean it's exactly the same as this? No. Or does it have the same relationship as this? Shows the same relationships. Okay? So the 3 equivalent forms will not be exactly the same as this equation, but they're going to have the same relationships. Okay? So right now, what's the relationship between A and F? Direct. What about A and M? Inverse. So as we go through, those relationships are going to stay the same. So A and F will still be direct. A and M will still be inverse. What's the relationship between F and M? Okay, this is like we saw for K, right? K equals X or Y over X. So is that direct or inverse? K equals Y over X, direct or inverse? What is it? Direct. Okay, so that's direct. Like capital letters, because you can't really see those I's and those. There you go. Why is that better? You guys know what the I's and the D's stand for, right? And no, it's not did. It's direct, inverse, direct. Okay. All right, so we got to make sure those relationships stay the same. Now, if I'm going to find the equivalent forms of A equals F over M, that means I'm going to take this equation. What do I have to do with it? How many variables do we have? 3. So if I want to find all the equivalent equations, since I have 3 variables, I'm going to need 3 total equations. Right now I have 1 equation, so how many more do I need? I need 2 more, right? So I'm going to need to get 2 more equations. So to get those 2 more equations, instead of just solving for A, I'm going to solve for F, and I'm going to solve for M. So one time we're going to solve for F, and another time we're going to solve for M. I use gonna a lot. I'm trying to not use gonna. And all right. Personal self-conscious thing. All right. So we're going to solve for F and solve for M. Does that make sense? All right. I said all right again, didn't I? All right. All right. So we're going to solve for F. So to solve for f means I want to get f by itself, right?
Yeah.
So how do I get this f by itself? Times by m. Right? So my m's will cancel. What am I left with here? MA equals F. Now let's check to make sure. Are F and A still direct? Yes. Are F and M still direct? Yeah. So my equivalent form still kept those same relationships. All right, does that make sense? Now to do this, what did I just use? No, I did not use a T-chart. We're not calling it T-charts anymore. You've now graduated from the middle school mentality, so we're leaving those T-charts across the street. All right. So what is it?
Algebra.
Algebra. We used algebra. It's like a T-chart, but not entirely. Okay? We used algebra. All this is, guys, is just algebra. But instead of having numbers, I'm using letters. Okay. So, solve for M. This one's a little more fun. Because my M is on the bottom. Right? So over here, the F was on top, right? We just had to get rid of the M and we were all good. On this one, the M is on the bottom. So if I just get rid of the F, is that going to fix it? No. We have to get the M off the bottom first. Right? So how do I get the M off the bottom? Multiply by what? M. Looks very similar to the one we just did, doesn't it? So the M's cancel. MA equals F. That's where we ended over here. Right? But now I want to solve for M, so I have to get the M by itself. So what do I do next? Divide by A. So that means M equals F over A. Okay. So are M and F still direct? Are M and A still inverse? Yeah. Keeps our relationships the same. I just rewrote it in a different way. Does that make sense? Not that much. So here I have three equivalent equations. All these equations are equal, meaning they have the same relationship. You kind of don't get it? We'll do some more. Yes. You don't need to give me a whole pass. All right. Number 2. P equals mv. All right. This is my momentum equation again, right? Right now, P and M and P and V are both. P and M and P and V are both direct. What about M and V? What are they? It's like this is like my K now, right? K equals MV. Which one's that? Direct or inverse? Inverse. So M and V are inverse. P and M and P and V are direct. Does that make sense? Yeah. Okay. So I'm gonna write equivalent forms. So that was okay. It wasn't all right. All right. I'm gonna write equivalent forms. Okay. I need to solve this for what? I need to solve this for M. And we need to solve for V. So, which one do you want to do first, M or V? M? We can solve for M first. So, P equals MV. How will I solve for M?
Divide by V.
Divide by V. V is being multiplied, so we do the opposite of multiplication. V's cancel out, so we have P over V equals M. Now, are M and V still inverse? Yes. Are M and P still direct? Are P and V direct? Yes, because it's like M is my K, right? K equals Y over X. So our relationships are still the same. Are there any questions about that one? I want you guys to try this one on your own. Okay, so real quick, we're going to try it in about 30 seconds. I think we'll handle it in 30 seconds. So try that one on. P equals MV. Solve for V. Solve for V. Need help? Let me know. little longer than 30 seconds. But right now we have multiplication here, right? Right? I want to get the v by itself, so how do I get rid of multiplication?
Divide by m.
Divide. So we divide by the thing we don't want anymore. M's cancel. So p over m equals v. Are p and v still direct? Yes. Are m and v still inverse? Yes. Are p and m still direct? Yes. So these three equations say the same thing. Just different ways. Was it easier? It was a little bit easier. Any questions on 1 or 2? No? Okay, let's try 3. Okay. If I'm writing equivalent forms for 3, that means I need to solve for what?
Z.
Z and x. So we're going to need to solve once for z. And we're going to need to solve once for x. So solve for z and solve for x. Think you guys can do this one? Yeah. Give 3 a shot. Right out. Going okay? Too easy for you? Not really? You're just going to hang back here and take a nap then? Yeah, that doesn't sound like a good idea. Where's your paper? There's some up there by Jessica. There's some back here by the boxes. Okay, those might be helpful for you. Some is completely up to you, but I think it's a good idea. Andrea, you done already? No? Remember that camera is recording now too, so if I want to figure out what you're saying right now, I can just watch the film again.
Talking about hump day.
Oh, what?
Hump day.
Oh, today's hump day.
Yeah.
I love that commercial. What day is today?
Hump day.
Joanna, how's it going? Good? If you need help, we know, guys, if you need help, raise your hand, please.
Seriously, don't get how to do it.
Seriously, don't get how to do this? Who's that? Andrea? Yeah. You're too busy talking about hump day.
No, but this don't make sense. Like, how do you know if it's direct or indirect? If they're the same thing?
It fits this format.
Inverse.
Okay. So, number 3, right?
Yeah.
Y equals z over x.
So that would
Okay.
be inverse.
If I'm looking at y and z, that means x is a constant, right? Right, so we did yesterday with the tables.
Yeah.
If I'm worried about y and z, that means x is a constant. So y and z looks like this one, right? Because the z is on top of the fraction.
It looks like this one at top.
Looks like this one. How? I can write that as like this: y equals x over k, right? And then sum that one. Now I don't want to get in the habit of doing that because k is a constant, and constants can be fractions. So like if k is 1/4, right? It's x over 4. Okay. So that looks like that one. All right, does that make sense? All right, so let's solve for z. Solve for z. Jordan, what do I have to do first to solve for z? What do you think? Times by x. Why did I times by x? Why did I times by x? Why did I multiply by the x? Good, so cancel out the x. You got x on bottom, gotta get x off the bottom. Right? Cancel. xy equals z. Does that make sense? Relationships are still the same. Z and y are still direct, z and x are still direct. X and y are still inverse. So let's solve for x. So we start with the same thing. Right? Now I'm going to solve for x. What's my first step?
Multiply.
Multiply by what, Jamira?
Z.
Nope.
Ah.
X. Okay? If I was going to get rid of the z, I'd have to divide because it's on top. Okay? Multiplying only gets things off the bottom, right? So I got to multiply by x. Multiply by x. So those cancel, right? So now I have xy equals z. It kind of looks like what we have over here, doesn't it? Right? Now what do I do? Divide by what? Y. So x equals z over y. We divide by y because y is being multiplied by x, and division cancels out multiplication. Okay. All right. Any questions? Okay. Quick word or a quick hint for everybody. If there's a number on bottom, what should you do first, regardless of what you're solving for? If there's a number on bottom, what should you do first?
Get it out of there.
Get it off the bottom, multiply, right? Get that number off the bottom first, right? All right, I want you guys to try number 4. I want you to figure out what you got to solve for, and I want you to solve it. Okay? Try number 4. We got to solve for T and S, good.
Now I finally am actually interested in math this year, but I actually get it now.
All right, that's good. We're actually doing math now instead of just talking about ourselves.
Yeah.
That usually helps. Or if you need help, please let me know. Can't help you unless you ask for it. I can't help you if you don't ask for it.
I know you said that.
Sounds like we're done, huh?
Yeah.
No.
Well, it sounds like we're done.
Would 4 be like 8? I mean 1. Maybe like 1. Oh, and
All right, ready? No?
Oh,
A little more time. I got people talking about nothing.
I was asking for help.
Just gonna listen to it later to figure out your conversations there.
Yes.
I have software where I can pull out specific voices too, so if you're all talking, I can't figure out what I can figure out.
Really?
That's a complete lie.
If you find something funny, you should just play it out for the entire
You can watch it yourself by going to my YouTube channel or going to my Facebook page.
Why would you do
What's
that?
Mr. Branch Keita?
Wait, so even
Shameless
when you're not
promotion, you got that right.
so
What?
even when you're not up here talking, it's still recorded.
Well, right now it's recording. Like, it's just recording right now.
Will you like edit that out though?
No.
No, we just have a whole entire video up there.
Yeah, it's
So
easier to
whoever's
do.
watching this video, watch
Yes, Audrey, I have a question.
Where the edit- where-
Go deep.
What? I don't know, but I
Okay, we'll go through it. If the question pops up again, let me know, okay? Alright, so this one, what do I have to solve for?
T and S.
We gotta solve for T. We gotta solve for S. I keep my blue-green going.
It sounded like you said booger.
Oh, blue-green.
For a second.
Can keep those going too, it's fine. Alright, equals T over S, right?
Yes.
So we're gonna solve for T. So what's my first step, Jordan? Yeah, pay attention.
Multiply.
Maddie?
Multiply by S.
Good.
That
I was trying to answer that tomorrow. Sorry. I want to hear my voice one.
Okay. Alright, so S times R is SR, right?
Yeah.
Or you can write RS, same thing. These cancel, so it equals T. Next one, solve for S. So we start with the same equation, right? Now what's our first step? Raise your hand if you have it. Bruno. How do you do that? Good, you gotta multiply by yes, nice. Okay. So now these cancel, so once you give me SR equals T, right? Okay. What is our next? Maddie?
Divide by R.
Divide by R, good, because I want to solve for S. R is being multiplied, so divide by R. And we end up with, right over here, S equals T over R.
I get it.
Does that make sense, guys?
Yeah.
Okay. Are there any questions?
Yeah.